And I'm doing the introduction for the Amazon Book Reviews Natural Language Processing Final Project Presentation. We have already seen before, the team members for this project are the project leader Jimena, data lead Gracie, technical lead Aiden, and writing lead Christopher. And we chose to do a sentiment analysis of Amazon Book Reviews. This dataset uses a Kaggle dataset that has 3+ million reviews and 200,000 unique books with usable data for analysis. And our goals for this NLP project is to predict star ratings from review text, identify what makes reviews helpful to help readers, and uncover patterns between sentiment and book ratings. To start this off, I began observing the category ratings and helpfulness trends, and I pulled the top 10 categories based on the highest average ratings. And we can see that this ranges from 4.3 and 3.9, with the highest being juvenile fiction and the lowest being computers. And the top 10 genres are all within a narrow range, which shows that there's a consistently strong satisfaction across all these categories, and that the genres like juvenile fiction and religion seem to have higher demand in modern times. So it just suggests that more people are reading it for marketing techniques or are very in demand to read right now. I think that even small differences in average rating can help highlight which genres perform more reliably, because if you want to sell or begin publishing certain books, you want to make sure that it is in line with the market's demand. And moving on to the right side with the helpfulness ratio for extreme ratings, only including 1-star and 5-star ratings, I found that 5-star reviews had a much higher median helpfulness score, which says readers tend to review positive reviews as more useful. In contrast, I found that 1-star reviews showed a very low median in helpfulness reviews, which showed that they're not very helpful. Although negative reviews exist, readers often rely more on positive experiences, and I think that this is important because we can begin looking at the quantile ranges where there is much higher outliers in the helpfulness rating if it was scored a 5, while the less helpfulness rating or the less 1-star ratings, it is more normally distributed. So I just think it could be more helpful or reliable to look at the left side rather than the right side. And I also wanted to mention that most reviews automatically default to 5 stars as well, which could explain the helpfulness outlier. And to look at the sentiment patterns in authors, the highest sentiment books and authors show which titles that consistently use positive language and people that enjoyed reading this. Moving on to the right side image, we can see top most reviewed positive reviewed book is The Choral Experience, Literature, Materials, and Methods, while the lowest can be Targeting Pronunciation, Communicating Clearly in English. These books can include a mix of technical guides, cookbooks, biographies, and fiction, so positivity isn't limited to one type of book. The lowest sentiment titles show the opposite pattern reviews with more negative emotion, frustration, or even disappointment. This helps readers quickly identify which book or authors tend to generate positive versus negative emotional reactions. I think for publishers and sellers, I think that this can be helpful to find areas where customer experience is strong and where it needs more improvement, and it's helpful to see which authors are reliable and if you should generally take a chance on reading a book or another.
Although there are no official numbers available, it's estimated that there are between 30 and 50 million books available for sale on Amazon. These can be audiobooks, books published by small organizations or independent authors, popular books, unpopular books, good books, bad books, that sort of thing. It'd be unreasonable to expect users to manually browse each of these books to find one that they like. As such, there needs to be a way to sort and recommend the books that the users will prefer. Therefore, we will use a text analysis system to rank books based on the sentiment of the review and how other users rate that review. If it's successful, personalized book recommendations can be based on a user's review patterns. In this project, we have a few questions that need to be answered. The most important one is there a review? Does review sentiment correlate with star ratings? And from the research we've conducted so far, we found that there is a correlation between sentiment and star ratings. Specifically, the more positive the sentiment of the review, the higher the star rating. And by that token, the more negative the review, the less the star rating. So 1 star for negative reviews, 5 stars for positive reviews, that sort of thing. We also wanted to know what makes reviews helpful to other users. And for this one, reviews can help convince other users to view or buy a product. In this case, reviews will want to convince users to read the book that's being reviewed. It can also help users to stay away from books that they won't like. We've also found that although there are some common words that can be used to associate positive or negative reviews, there is no structured format to the reviews themselves. One review could be written clearly, while another could be written using the bare minimum. This makes it difficult to find specific linguistic patterns in the review. So now that we know that review sentiment correlates with star ratings, we can begin using the data to now analyze reviews and predict the star rating of that review. From this, we can also see if there are patterns in reviews that other users find helpful. So one specific problem we encountered with the files was the size of the datasets. The size of the files that needed to be downloaded were around 1.6 gigs, and there were over 3 million reviews, which significantly added to the processing power needed to load and manipulate each data set. This also meant that it took a significant amount of time to process each data set.
For the books dataset, the missing fields like description, author, publisher were filled with unknown, and the categories column was cleaned by removing brackets and quotes, and the ratings count was converted to numeric, and any invalid values were replaced with 0. For the reviews dataset, missing rows from the review scores were removed since that's the target variable, and any missing fields in the review column was filled with empty strings to ensure that all of the reviews contain usable text for the later analysis. As far as sampling and merging, we randomly sampled 10% of the reviews dataset and merged the sample reviews with the book metadata using the title, and then the clean dataset was exported for the final analysis. So as far as exploratory data analysis after the data cleaning and merging, from figure 1 you can see that a majority of the books have 5-star ratings, and then from figure 2 with the top 10 book categories, the mean rating is a 4.22 with the median rating being a 5.0. So as far as the initial findings and observations, the first thing was sentiment polarity versus rating. So the sentiment polarity was calculated using TextBlob, which assigns -1 for very negative, 0 for neutral, and 1 for positive reviews. So from figure 4, you can see that there is a positive correlation between sentiment and ratings. So as the sentiment becomes more positive, the average rating tends to be higher. And then for review length patterns, figure 3 and table 3, in general, longer reviews are rated as being more helpful, with the review length and the helpfulness ratio being weakly positively correlated.
Challenges encountered. As we worked through this technical portion of the project, we encountered several challenges that shaped the workflow and affected our choices. The biggest issue came from the sheer size of the dataset. With more than 3 million reviews, loading the data into Google Colab took extremely long and often caused memory failures, which slowed down pre-processing. But when we switched to Kaggle, load times improved because the data is natively stored there. But Kaggle also restricts external library installations. This forced us to adjust our environment setup and adapt some of the tools we originally planned to use. We also had to deal with data limitations. Some reviews were missing price information, many had inconsistent formats, and certain text fields varied heavily in quality, from lengthy, detailed reviews to extremely short or empty ones. These inconsistencies required additional cleaning to ensure the dataset was usable. On the computational side, text processing tools that normally work well struggled to scale the dataset. So we had to test alternative sentiment approaches to reduce runtime. By reorganizing data loading, simplifying certain pre-processing steps, and selecting more efficient sentiment tools, we were also able to overcome these obstacles and keep moving forward with the project. Technical standing results, or what was completed. So despite the initial challenges, we were able to complete a strong technical foundation for the sentiment analysis. We successfully cleaned and processed millions of Amazon review entries by removing punctuation, converting everything to lowercase, removing stop words, tokenizing, and lemmatizing the text. After pre-processing, we transformed the cleaned reviews into numerical form using Bag of Words and TF-IDF. This gave us a feature space with tens of thousands of unique terms, allowing us to make quantitative comparisons between all of the reviews. We also ran document similarity tests to confirm that our TF-IDF vectors are meaningful. Like, for example, sample review pairs had similarity scores like 0.136, which showed the model could distinguish differences in writing style and sentiment as well. From there, we began initial modeling using logistic regression and naive Bayes to classify sentiment and examine how it aligns with star ratings. Our early results supported the larger findings of the group, where positive language generally correlates with higher ratings and negative sentiments aligns with low ratings. Overall, we completed the entire pre-processing pipeline, built the feature extraction system, and ran early modeling experiments that set the stage for more advanced analysis. Future possibilities or limitation. So looking forward, there are several directions we could expand this project, as well as limitations to consider. One major possibility is upgrading from TF-IDF to more powerful representation methods, such as word embeddings, which capture deeper semantic meanings. From there, we could explore transformer-based models, which have become state-of-the-art in NLP, and would allow us to better understand the context, tone, and subtle language patterns in all of the reviews. Another area for development is improving the recommendation system aspect of this project. With more time and computational resources, we could cluster similar reviews or analyze genre-specific sentiment behavior or personalize recommendations based on users' review history. We also see potential in scaling up our sentiment modeling to handle even larger subsets of the dataset more efficiently, but that may require more GPU-based processing or distributed computing, things of that nature. However, limitations remain. The dataset is large and very demanding computationally. Some reviews lack detail or contain ambiguous language, missing metadata such as price information, which restricts certain types of analysis. Even with these constraints, the work that we've done shows that natural language processing can uncover meaningful insights from millions of reviews, and future advancements could make the system more powerful, accurate, and also scalable as well. Thank you.